ice on buoys during winter and summer. These are typical unlighted buoys that are in use between Quebec City and Montreal. During high flow, the ice movement due to the current tend to push the buoy under the ice cover for short periods. However, at slack water, the buoy can remain under the ice for hours until the ice cover goes with the flow. In the springtime, this buoy could be affected by strong currents, making the buoy unstable and difficult to identify by mariners. Because of winter navigation requirements, the Floating Aids Network is composed of more than 350 lighted summer buoys that must be withdrawn in the fall and replaced with 167 unlighted spar buoys at critical locations for the winter season. The summer and winter buoys mooring system is made of a 4-ton cast iron anchor with 28 mm mooring chains attached to the buoy with a bridle. Lighted buoys are a night navigation requirement for commercial shipping on this particular segment of the channel. From the time lighted buoys are withdrawn and replaced in the spring, most ship owners will stop night navigation, resulting in increased transit time. Replacement of summer buoys with winter buoys must take place over a very short period due to potential impacts on shipping and, consequently, economic impacts on ship owners. Stopping lighted aids navigation services means doubling the number of pilots boarding each ship at a significant cost for ship owners. Please note the condition of the buoy when we come back after the winter. To minimize adverse impact, summer buoy removal must be executed as late as possible in the fall. If the removal is delayed, the buoys will ice up, tip over, or sink, becoming hazards to navigation. Retrieving ice-covered buoys represents high risk for seagoing personnel. These operations cause tremendous pressure on resources which require tasking several vessels to the same area while maintaining search and rescue coverage over adjacent area. It is worth mentioning that the Canadian Coast Guard operates multitask vessels and overcraft, but has no vessel dedicated solely to buoy tendering. In the spring, ship owners expect that lighted buoys will be positioned as soon as ice disappears to be able to resume normal 24 hours operation with only one pilot on board. Any delay in installing summer buoys has a direct incidence on their operating costs. The four-season buoys would enable the Coast Guard to concentrate its buoy tendering and maintenance effort at times of the year when our vessels are available and favorable environmental conditions exist. Project objectives were defined through consultation with ship owners and Coast Guard staff. The objectives were to develop a buoy that can be kept in place for 2 years without any maintenance, be maintained during off-peak periods only, and provide visual and radar service day and night for 9 months of the year. The last sentence responds to one of the findings that it is technically impossible to guarantee an adequate service during the 3 most critical months of the year due to ice accretion on lanterns and ice pressure on the buoys. This presentation focuses on the buoys that needed to be developed for the most difficult area west of Quebec City. The operational criteria for the 9-month period during which the buoy must remain fully operational are a visual range of 3 nautical miles, a radar range of more than 2 nautical miles, an air draft of more than 2 meters, and a verticality that remains below 6 degrees of tilt. For the remaining 3 months, the buoy must withstand the harsh environment without damage and fully resume its operational function once ice has disappeared. The technical performance criteria were, for the hull, no permanent deformation would be acceptable. For the color, the retention of at least 75% of the surface paint and color after 2 years in service. For the lantern, the uninterrupted operation, even after the lantern has been submerged for long periods of time at temperature of 4 degrees Celsius. And for the battery and the electrical system to be maintenance-free for at least 2 years. The lower section of the 9.2 meters buoy consists of a watertight compartment made of 0.6 meter diameter steel cylinder. A 1-ton counterweight is at the bottom to ensure vertical stability of the buoy. The upper section is 1.3 meters in diameter. The thickness of the steel is 9.5 millimeters and reinforced with interior frame close to one another. This section contains 3 watertight compartments and is coated with the Inerca 160 paint system. The lantern used for this trial is the Sabic MPV3 model. This heavy-duty lantern, designed for demanding situation, has been used by the Canadian Coast Guard for a number of years. However, it has never been used in Canada under conditions as severe as those existing in these sectors. In this concept, the battery can be inserted from the top of the buoy, which facilitates maintenance. The primary battery used for the prototype is a battery manufactured by Celtec of Sweden. The models shown here are the 2 first prototypes developed for this section of the river. The 9.2 model is to be used midway between Quebec City and Montreal, while the future 10 meters long is to be used around Quebec City, where the conditions are even more severe. The prototypes were built and deployed for 2 full years. Initial deployments in ice-free water indicated exceptional vertical stability of the buoys. In current up to 5 knots, this new buoy showed resistance to ice impact and abrasion. In terms of structure, this buoy better maintained its circular shape than current buoys, despite experiencing 26 G accelerations when impacted by ice masses of many kilometers long and 1 meter thick, traveling at 5 to 6 knots. Comments from mariner and pilots confirmed the performance of this model. Not only were these comments favorable, but reports indicated that these type of buoys were well received by commercial users and pleasure craft boaters. However, reflectivity of the marking material was not suitable, and the technique of glass beads embedded in paint were rejected for not meeting minimum requirements for reflectivity rate. Research continues on that topic. The lantern, modified with the removal of the tilt switch, performed well during the trial period, despite water ingress found after retrieval. The batteries, retrieved after the trial, were opened to see how the inside withstood shocks. It was found that the internal battery cells had shifted due to impacts, and a total shutdown could have occurred at any time. The first trial of this buoy was done under relatively mild condition and light current to observe vertical stability. The next step of this project is to further test the lantern performance. More testing will determine if water ingress was accidental or if the conditions in which the lantern must operate exceed its capacity.